Look at this image. Orbit is the objective. Here, the black void of space surrounds the mission's final destination. Staying up here demands an incredible horizontal speed of nearly 28,000 kilometers per hour. Traveling upward is only the first step. This diagram illustrates a brutal principle known as the tyranny of the rocket equation. To push a payload to that extreme speed, you need a massive amount of fuel, but that fuel adds weight, and to lift that extra weight, you need even more fuel. The math is unforgiving. Building a single monolithic rocket massive enough to carry all that fuel up to orbital velocity makes it too heavy to get off the ground. NASA had to design a vehicle that broke itself apart. The solution relied on three distinct components: the winged orbiter, where the astronauts lived, a towering orange external tank holding liquid hydrogen and oxygen, and twin solid rocket boosters to provide raw lifting power. Engineers spent months inside the colossal vehicle assembly building at Kennedy Space Center, meticulously stacking these separate pieces into a single vertical unit. Once fully assembled, a specialized crawler hauled the towering stack out to Launch Pad 39A or 39B. This massive structure crawling to the CAD is a temporary, disposable scaffolding. It is engineered exclusively to survive the violent climb through the atmosphere. About 3 hours before launch, astronauts boarded the orbiter. While they strapped in, ground crews verified thousands of distinct technical systems. There was zero tolerance for error. A microscopic technical anomaly or a slight shift in wind patterns would immediately stop the mission. At exactly T-minus 6.6 seconds, the orbiter's three main engines ignited. They immediately began drinking hundreds of gallons of liquid hydrogen and oxygen per second from the attached external tank. Then, at T0, the solid rocket boosters fired. The heavy hold-down bolts snapped open, and the multi-ton stack blasted off the pad. The moment the shuttle cleared the launch tower, a rigid timer began. Every second of the ascent was a precisely scheduled race to shed mass. For the first 2 minutes of ascent, the Space Shuttle relied on those twin solid rocket boosters to provide the brute force necessary to punch through Earth's thick lower atmosphere. Solid propellant burns fast. The moment those boosters emptied, they instantly transformed into heavy, useless dead weight. At the 2-minute mark, explosive bolts severed the connections. The heavy side boosters detached and fell away from the central stack. They tumbled back down through the atmosphere, eventually deploying parachutes and splashing into the ocean for eventual reuse. Jettisoning these empty metal casings was a mathematical necessity. Keeping them attached for even a few extra seconds would have dragged the orbiter back down to Earth. Now much lighter, the orbiter's three main engines shouldered the entire burden. They continued burning fuel from the colossal external tank to push the vehicle into the vacuum of space. 8.5 minutes into the flight, the vehicle reached its next critical milestone, main engine cutoff, or MECO. The primary engines finally shut down. At this altitude, the external tank was empty. The explosive sequence fired again, and the tank was jettisoned from the belly of the orbiter. Unlike the solid boosters, the external tank was not designed to survive. It drifted downward, breaking apart and burning up entirely upon re-entry. In less than 9 minutes, the towering, fuel-heavy structure that left the launch pad had been reduced to a fraction of its original mass. What remained was a solitary spaceplane coasting silently through the vacuum. To secure its place in space, the orbiter required one final maneuver. It fired its smaller Orbital maneuvering system engines, locking in its velocity at 28,000 kilometers per hour. Once established in orbit, the mission transitioned to operation. Astronauts were able to conduct zero-gravity science, deploy satellites, or dock with the International Space Station. Consider the physical contrast of this journey. It started with millions of pounds of explosive fuel and steel strapped to a launch pad, and it ended with a sleek glider circling the planet. The Space Shuttle defeated the relentless gravity of Earth through dynamic architecture. It solved the strict math of spaceflight by calculating precisely what to ignite, what to hold on to, and exactly when